Good morning, students. Welcome to geography class and welcome to EduKashow. Today we're going to be working on geography class, and with geography class you're going to be learning everything about that, what it is, and what is the most important things about geography. So this is for home, and I hope you guys take notes. Get a piece of paper or a sheet of paper or a notebook and start working with the topics or with the information that I'm going to be giving you. Alright, so let's get going to it. The first thing that we're going to be working on, and I've got it right here, we're going to be working on geography. So I'm changing my presentation right now so that you guys can see geography. So the title of today's class is 7th and 8th grade middle school by teacher Ike, geography class on EduKashow. Alright, so the first thing, or the very first thing we're going to be working on, and we're going to be getting to learn a little bit about this, is what are the roots of the word geography? Where does it come from? Where is the beginnings of this word? So the word geography can be broken into the two basic elements of geo and graphy. So geo comes from the Greek word for earth, which is the word Gaia or Gaia, and also meaning earth. It derives, or it comes from, the Greek as well. And the other part of the word is ography, which comes also from the Greek word graphene, which is to write about something or to draw something. So geography comes from two Greek words, geos meaning earth, and graphos or graphos meaning writing, which is writing about the earth or the study of earth, its formations and locations. So it is very interesting because since back in the day, since the days of the Greeks, people have been studying geography because they want to learn about the world. They want to really know everything about the world. What are the origins? Why is the world like this? Why do we have mountains? Why there's earthquakes? How do we find ourselves if we get lost? Or how do we find something or somewhere or somebody if we would get lost? We need to know about. And that brings us to the next topic. And I would like you guys to pause the video and take some notes about that. And the next part we're going to be learning is location. Basically, of course, location is actually where something is. Absolute location. For example, in this case, we have different topics or different meanings of location. The first one, which is the most basic one, or the most basic topic or subject, is location. The definition of location is, of course, where something is. Absolute location, it describes the exact location of a place. It is often described using latitude and longitude. What is that? Don't worry, guys. We'll get to see what longitude and latitude is. And there's also relative location. For example, I can describe where a place is in relation to something else. Example, Europe is north of Africa. Think about it for a moment. If I say absolute location, then I'm going to give you some numbers and I'm going to give you some coordinates to know exactly where something is. Okay? And in the case of the relative location, it's where something is in relation to something else. Okay? And that brings us to the next topic. As you can see, we're looking at two different planet Earths over there. You got an N, you got a W to the left, you got an E to the right, and you got an S. You got an S to the south. So this is latitude and longitude. In the case of the latitude, these are the lines of latitude that are measured north and south of the equator. These are these lines right there. So you're looking at them right now. Those lines, as you can see the red arrow right there, that is latitude lines. Those lines. Equator, which is the middle or like the half of the planet, is 0 degrees of latitude. 0. Other lines of latitude are called parallels because they are parallel to the equator, as you can see right there. It's got 0 degrees, which is the beginning, let's say. Lines of latitude are measured from 0 to 90 degrees north latitude. So latitude are lines that run side to side. These are imaginary lines. They don't exist. We, the humans, have created this so that we can know how far to the north or how far to the south something is located. That little square, it's a 90-degree angle. All the way up, you're going to see that is actually 90 degrees to the north. So you're looking at 90 degrees to the north. In the case of the south, 90 degrees to the south. And now, if we want to know where something is located in relationship to how far east or how far west something is, then we have longitude. So lines of longitude are called meridians. Take notes. The prime meridian or Greenwich meridian is 0 degrees longitude. It is called Greenwich because it actually crosses through a city called Greenwich. All other lines of longitude are measured east or west of the prime meridian. Longitude is measured from 0 minus or 0 to 180 degrees east and west from the prime meridian, as you're looking at into those illustrations right there. These lines meet at 180 degrees, and this is called the international date line. Write it down, take some notes. If you need to pause the video, go ahead and do it. This line is both east and west, as you're looking at in that illustration right there. So now we know what would be the technique or the process to know exactly where something is located. How to know or how to know where to go if you're looking for a specific location, which is an absolute location. And of course, we have the global grid, which is using latitude and longitude. The global grid, it's actually just a grid, and you're looking at this image right here, where you're going to be looking at the whole planet, and it's got some sort of like a grid. In the case of the latitude, you're looking at the numbers starting off in the middle, which is the equator from 0. If you go all the way up, in that illustration we have plus 30, plus 60, plus 90. And then if you go to the south, you got minus 30, minus 60, and minus 90 in the lengths of latitude. This is telling us how far north or how far south something is located. In the case of the longitude, yeah, 0 degrees in the Greenwich meridian. If you go to the east, you're gonna find that in that grid, the number is telling us plus 90 and plus 180. And in the case of the west, it's gonna be something about, in this case, we're looking at minus 90 and minus 180 degrees. So this is basically how latitude and longitude would look in a bigger scale, of course, our planet. So we can know by using coordinates to, find a specific location. So every measurement using latitude and longitude has a set of coordinates. One coordinate will be for degrees latitude north or south of the equator, to know how far south or north we're looking for something. For example, 30 degrees north latitude is this line. 30 degrees south latitude is that line. So the other coordinate will be degrees east or west of the prime Greenwich meridian. In that particular case, example, you're looking at that purple line right there. 30 degrees east longitude is that line. Easy, right? It's just very basic, very simple, very easy. If you need to rewind the video, you can go ahead. Just remember to keep going. And of course, the most important thing is take notes, because there's of course going to be an exam that you guys are going to be taking, and you're going to be getting your grades, of course. 30 degrees west longitude is that line. You're looking at that example right there. So you put the two together and you have a location. For example, 30 degrees north and 30 degrees to the east would be that little pink line right there, telling us exactly where something is located. So latitude should always be listed first. Again, latitude should always be listed first. So your north or south will be before your east or west coordinate. Once again, latitude should always be listed first. Latitude. Your north and south would be before your east and west coordinate. Okay? If you guys have any questions, of course, go ahead and tell me in the comments. I'm going to be answering every single question from you guys. And if you need to check something, remember you can always pause if you need to take your notes, or you can always go back to the video so that you can know exactly what something is or what something means, or if you need to review something, you can just go ahead and do it. Remember, this is the study of geography, and the study of geography should always be fun. So, over here, we're looking at an Australia map, right? In this map, you're looking at the coordinates and you're looking at the map legend. If you look to the left, to the bottom of this map, you're gonna find that it says capital city and of course other cities. So the capital city is portrayed or shown as a little circle with a star, and the capital city of Australia right there is shown as Canberra, right? Other cities are just shown as small black dots all across that map. You're looking at the Indian Ocean right there, and of course you're looking at those numbers, and besides each of those numbers we have a letter. That means, for example, if we start from the left, we got 15 degrees south. If we go a little bit to the bottom, you're gonna find 20 degrees to the south, 25 degrees south, 30 degrees to the, for example, south again. And in the case of all the way to the top, to the left, 100 degrees east, 150 degrees to the east, and so on and so forth, right? So, we need to find the latitude and longitude of the following cities, and this is going to be the first exercise that we're going to be working on. I'm going to provide to you guys in a link that you're going to be showing in the description of the video, you're going to be finding the link to be able to do this activity. The first thing you're going to find is, tell me the latitude of that first city, which is Alice Springs, by looking at those numbers. Of course, you're going to have to draw out your conclusions to know exactly where something is located. Like I said, this is super easy. You're going to have a lot of fun by working on this. Of course, 22 degrees to the south and 133 degrees to the east. In the case of the other cities, how would you do that? Look at Brisbane, for example, to the east of that map, or to the right of our map. You have Brisbane right above Sydney. What do you think the coordinates will be for that one? So I'm not going to be showing right now the answers, because I know some of you guys are going to be waiting for that. So what I'm going to be doing right now, I'm just going to be showing the logo of EduKashow so that you guys cannot see the answers, because this is an important practice for you guys. Alright, very good. In the next topic of today, and we got only a couple of minutes left before we go, we have map projection. Map projection. So we're looking at maps right now. So whenever we attempt to take a round globe and make it flat, then we're going to be running into a problem. What do you think that is? What do you think we're going to be running into a problem if we try to flatten a globe or a ball? Picture you have a basketball. Imagine that you could, cut it. I mean, of course, getting the air out of it or the gases out of it, and try to make it flat. How would that look? What would happen to it? Is it going to be perfect? Is it going to be like a rectangular shape, or is it going to be a perfect rectangle? I'm not sure about that. It's impossible to take a round earth and make it look flat without stretching or messing up part of the earth. There's going to be distortion. This part that gets messed up is called distortion. It gets distorted. It doesn't look nice. It's not perfect. It's not good for studying, right? So there are several ways that a map can be distorted so that we can know exactly how to work with that. For example, you could have a distortion of area, which is the size of the land masses, which is going to change, of course. It's not going to be exactly the same. Look at the moving GIF over there, that moving image, and see how, like, in the middle, for example, the United States or Mexico, they get like larger, and then when it goes back, it gets like really small. And look at what's happening to the poles. Like if you go all the way to the north or to the south, look at how that is getting modified if we try to make this, with distortion. The lines also get different. So there's a lot of solutions for this. We can also have distortion of shape, which is the shape of the land masses. They're going to change. You can have distortion of distance, which is the distances between the land masses. They're going to change, of course. And of course, you can have distortion of direction, which is between the land masses. The direction between the land masses, of course, is going to change. So the first way to portray or to do a flat projection of the planet would be the Mercator projection. And this is called Mercator because it is a cylindrical projection. So it is distorted greatly at the poles and is least distorted near the equator. So this navigation is useful for naval navigation because the direction are accurate. This kind of map. So you're looking at the planet over there in the diagram, the planet Earth. And what we did with that, we just changed the way of the sphere and turned it into a flat, like if you would have a cardboard and you have like a cylinder, right? And then if you would open it, that's the way it would look. It is like if we would take like the projection of the sphere, we take a picture of it and we try to make it flat. So this is called the Mercator Projection, and that's the example. That's the way the map would look if you would use that projection. Take note. In the next projection that we have over here, it's going to be the polar projection. So the polar map projection is a planar projection. The major problem with it is that it does not show all the Earth at one time. It is useful for airplane navigation because distance is shown correctly. So look at those examples. In the case of the diagram from the bottom of my slide, you're looking at a plane of projection, which we're taking like the very top or the top hemisphere of the planet Earth. And let's say that we took a picture from like above the north of our planet Earth. And what happened? We only have the upper part of it. We only have the northern hemisphere of that planet. So we could take pictures or projections of other parts of the planet so that we could picture some of it, because we're not going to be able to picture everything at the same time with the polar projection. It is called polar because we can take a picture from the top and from the bottom, and you can see what that is going to show. It's good for airplane navigation and they use it all the time, so this is a great way of showing or using it for specific navigation. But you have to know exactly what your map is showing you. Okay? Take notes. Next, we've got the Robinson projection. And in the case of the Robinson projection, you're looking at the whole planet. It's like if we would just like took a huge picture of it and then we just flatten it out. In this case, this one is compromised. What does that mean? It minimizes distortion and it is used most often for data representation because it has minimal distortion. Okay? So you're looking at some very brief distortion. You're looking at a way to show the whole planet. It's not flat. It's not a square. It's not a circle. It's actually kind of like a oval, doesn't it? Right? Look at that. Very interesting. If you look at that diagram from the bottom, that's the way it would look. You have another picture up here, and that's the way that would look. So those are the projections of the maps. We still have more. And of course, information can come from many geographic sources, right? But that's going to be a topic or a subject for our next class, which is going to be coming on next week. The only homework that you guys have is to do the locate those Australian cities in that map, and I'm going to be attaching that activity for you guys over here in the link in the description. If you like this video, hit the like button, subscribe, and hit the little bell so that you can get notifications for every single class of geography or every single class of EduKashow that I'm going to be showing for you guys over here. Thank you so much for being here, and I'll see you guys next week. Bye-bye.